Hi, my name is Alexi, and I'm the Director of Training here at Opto 22. In this screencast, I'd like to introduce you to some of the features of PAC Manager. What is PAC Manager? It's a configuration and maintenance utility used with all SnapPAC system controllers and brains. Let's get started. Here's PAC Manager, which is used to configure, inspect, and troubleshoot SnapPAC hardware. PAC Manager works with the SnapPAC S-Series and R-Series controllers, as well as all the SnapPAC brains. PAC Manager can handle a variety of tasks, including assigning and changing IP addresses, upgrading firmware, configuring I/O advanced features and protocols, and inspecting and testing I/O points. For this screencast, I'll be using a SnapPAC Learning Center. The Learning Center has a SnapPAC R, which serves as both a controller and I/O unit processor. Since the SnapPAC system is based on an Ethernet network, the first thing I need to do with the new PAC is assign an IP address to the eNet1 connector, which is the primary Ethernet connection. I'll go to Tools, Assign IP Address. When you power up a new SnapPAC controller or brain, it broadcasts its MAC address and a request for an IP address. MAC addresses are listed on the label on the outside of the hardware. I'll double-click the MAC address of my SnapPAC R controller. Then I'll type in the IP address and subnet mask that I want to assign to it. I'll click OK. To send the IP address, I'll click Assign. To verify the address, I can click Test. This reply lets me know that my PAC hardware responds to the new address, so I'll go ahead and close all of these windows. Occasionally, you may want to upgrade the firmware on your PACs, perhaps to use it with a new version of software. I'll go to Tools, Install Firmware via Ethernet. This link here will take you to Opto 22's website to get the latest firmware. On this webpage, I'll select my hardware and the firmware file that I need. I'll click Download Now, and I'll click Save. I'll save the firmware file to my desktop on my PC, and I'll close the download dialog. Back in PAC Manager, I'll browse to select the firmware file on my desktop. I'll select the file and click Open. I'll select the IP address of my PAC R and click Execute. This step downloads the firmware file from my PC to the PAC hardware. When it's done, I'll click Close. Here's one more feature that's extremely useful for network maintenance. I'll select Tools, Find Opto 22 MMP devices. I'll click Find, and PAC Manager will list all of the Ethernet-based Opto 22 devices on the network, including their IP addresses, firmware versions, and part numbers. Now I'm going to open up a configuration file that I already created by exporting my I/O configuration from my PAC control strategy. I'll go to File, Open. I'll select my tag database file and click Open. You can also create this file from scratch in PAC Manager. You should use PAC Manager for I/O configuration if you aren't using PAC Control, if you have multiple I/O units whose configurations are identical, or if you want to configure communication protocols such as PPP or SMTP, or if you want to configure special purpose modules. In this configuration file, I have one I/O unit, which uses the PAC R as the I/O processor or brain. Taking a look at the I/O unit, you can see I have 7 modules on this rack. Notice they're a mix of digital and analog, including the high-density 32-channel digital I/O modules. PAC Manager can also configure special purpose modules, such as Wiegand, Profibus, and motion control modules. For example, if I select serial modules, I can set up the configuration parameters for the serial devices connected to the module, such as baud rate, parity, data bits, and stop bits. PAC Brains and the PAC R controller have a lot of built-in functionality at the I/O unit level. Let me show you an example of an event message, which is simply data and text that can be sent by the brain in a variety of ways. In this example, the information about the low tank level will be sent via email and via SNMP trap. The data sent will even contain the current value of the tank because I used a plugin value here in the message body. The Communications button is used to configure the various protocols PAC brains and controllers can talk. For example, for the email message, I can specify the address of the email server. I can also implement some IP security. If my PAC hardware will be connected to a modem, I can configure the PPP or point-to-point protocol. I can set up both incoming and outgoing communications. Once I've finished my I/O configuration, I need to send it to the PAC R. I can even send it to several brains at once if they have similar configurations. I'll select Tools, Send Configuration to I/O Unit. I'll select the IP address of my PAC R and click Send. This programs the brain with the features I've specified. Now let's go to the Inspect mode by clicking on this button here. The Inspect mode is used to look at the hardware status and to test I/O. First, I need to select my device from the list. If my PAC's IP address wasn't listed, I could just type it in. Next, I need to click on Status Read. There's a lot of useful status information here, such as the firmware version. There's also a lot of diagnostic information, such as Ethernet errors. On the Status Right page, I can set various system parameters. For example, I can configure a controller's secondary IP address, which can be used for segmented or redundant networking. Other useful commands include the ability to store the configuration to flash and to reset to defaults. Next, I'm going to investigate the local I/O points. The Digital Bank button lets me see the status of all digital points on the I/O unit at once. This information is shown here as a bit mask in hexadecimal form. To see an individual point, I'll click Digital Point. I'll select the module number, which corresponds to its position on the rack, and then the point number. Currently, the point is off. If I turn it on by pressing the switch down and clicking Refresh, I can see the point status is now on. I can also use this screen to turn on points. I'll select Module 1 and then point 3, which is a digital output point. I can then turn the point on or off with these buttons here. This feature is very useful for troubleshooting your system. Now let's take a look at a high-density digital module. These aren't included with the Learning Center, but I've added them for purposes of demonstration. I'll select Module 6, which is a high-density digital output module. I can view the status of all 32 points. Because these are outputs, I can toggle the state of a point by double-clicking on it. Finally, let's take a quick look at some analog I/O. I'll click Analog Point. I've got an ICTD temperature module in position 3 and an ICTD probe connected to point 0. I can see it's about 78 degrees in this room right now. If necessary, I could recalibrate my analog inputs by adjusting the gain and offset over here. Now I'll select Module 2, which is an analog output module. Point 0 is connected to my meter. If I want to test my meter, I can type 5, for example, and click Apply, and my meter moves to that value. Thanks for watching my PAC Manager screencast. Be sure to check out the other movies and flash presentations in the Learn section of our website. See you next time.